DVDs of all of the talks here at The Last Hope are on sale right outside in the vendor area here on the 18th floor. And if you have a talk similar to relationship hacking or on another sort of screwball topic or something very serious that you want to talk about, go ahead and sign up for the 4th track in Zusa. There's still a lot of open slots left. This room is so packed. It's never this packed on a Friday. I probably shouldn't say this, but I'm kind of afraid of what's going to happen on Saturday and Sunday when, you know, the people with day jobs show up. And so, okay, it looks like Mitch is getting ready to go. It is my distinct honor and privilege to introduce Mitch. Basically, anything, you know, Mitch is heavily involved. Obviously in microcontrollers, TV-B-Gon's brain machines. He's involved in the hackerspace effort that's going on in San Francisco right now, NoiseBridge. You have an awesome resume, and I love your hair. Give him a round of applause just for his hair.
Let's see. I need to...
I mean, I can keep throwing compliments up here at you, you know.
Yeah, just give me one sec here while I tell Windows to do what it's supposed to do rather than
that's kind of a futile effort, isn't it?
Yeah, it is.
But you know, while I'm here and wearing my Hackerspace Village logo, if you're interested, obviously if you're here, you're interested in microcontrollers, you're interested in design, please come check out the microcontroller workshop going on in the Hackerspace Village. We also have right next to the microcontroller workshop circuit bending. So if you're interested in making old electronic things make noise in ways that they're not supposed to make noise, check that out. Also, we have a live video feed to the Meta Lab in Austria right now. I know some of you who know about the Meta Lab know that they have this really awesome phone booth, and right now there's a demo scene conference going on at the Meta Lab in Vienna right now, and as one of the items of that conference, people are controlling a little car that has a webcam on it that's roaming all around the Hackerspace Village, and so that, you know, people are seeing, they look up, they bounce into people, things like that. It's being controlled from Vienna, and right now they're working on making a live link so that people here can communicate to the Meta Lab in Austria right now. That's all going on in the Hackerspace Village. The Hactory just showed up. They've got a lot of cool stuff going on. NYC Resistor is on the way. And also at 2 o'clock, the Hackers Mart is opening up in the Hackerspace Village. If you have any sort of need for LEDs, components, solder, other things like that, or if there's things that you need, if there's a charger that you can't find, if there's other things that you'd like, we actually, around the clock, are going out and sourcing these things in New York City so that you don't have to leave the conference. We will get it for you and bring it right here. And actually, I know this is self-serving. Could I get a round of applause for the people who are out in New York City during Con finding chargers and stuff for you guys so that you can stay here? I think that's awesome. All right, I'm not going to cut into any more of Mitch's time. It's my great honor again and privilege to introduce to you guys Mitch Altman. Give him a huge round of applause right now and when his talk is over.
Hey everyone, I hope some of you at least got more sleep than me last night. I'm envious of you. So I started this company, Cornfield Electronics, to put out my one and only product, TV-B-Gon. I didn't plan on running a business. I'm not a businessman, but the world is a weird place. So I put together this workshop and this talk to try to give people a hardware bug. I think that it's really great to be able to build cool things. And I can teach anyone to build cool things. I've taught thousands of people just with this workshop that I've been doing. And this includes people who've never even sewn a button or soldered ever before. So if you're interested in learning or want to continue what you've already learned, feel free to come to my workshop. I've got lots of solder irons. I can teach you how to solder if you need to, give you refreshers. I have lots of parts, and I'm only charging just slightly more than what I paid just so I can break even for coming out here. So I just want to pass along what I think is just a really cool thing to do, which is to play with hardware and you know, not be stuck with the corporate crap that we would only have available otherwise. So I have some ideas of what cool projects are. Here's a few that I think are cool. TV Be Gone and a few variations. The last talk was Limor and Phil. I worked out a TV Be Gone kit with her, and that turns off TVs pretty far away, like 150 to 200 feet. The TV Be Gone Pro I just released turns them off at 100 meters. It's kind of nice. I couldn't resist. I mean, even though it is the Hotel Pennsylvania, I turned off all their CNN TVs yesterday with the push of one button. Today, they didn't work. Excuse me, a manual said that they actually put tape over all the sensors. So. And I'm also sorry to say that the TVs in the elevators are not remotely controllable. I'm tempted to hurt them, but it's the Hotel Pennsylvania, and we don't want to make them angry at us. So anyways, I've hacked a whole bunch of projects from Limor's Mini POV kit. Now, POV in this case stands for persistence of vision. That's how our eyes make sense of the world. A little bit of the information sticks in our eyes and our brains after it's gone. And it's this kit here. I don't know if you can see it with all this light, but you wave it back and forth, and whatever you program it in with this programming port, you see pictures or words, whatever you program in it through the space you wave it through. And it's a really wonderful, cheap little kit that anyone can build, designed for beginners, and I thought it would be really cool to hack it to do a bunch of different projects. So here's a few of the projects that I did, and I'll be talking a little about them more in this talk. I also have parts to build all of them at the workshop downstairs in the mezzanine. So I have a new project that I worked out with my friend Rolf. We are part of San Francisco Microcontroller Club, and it's kind of interesting here in our 21st century that there are a whole bunch of geeks in big cities that get together and form clubs about microcontrollers. And the meetings are pretty big. So here's the thing. It's let me reset it, and oop. So it has a library. You can hack it, and it has a sound library, a visuals library. This one's kind of like Pac-Man. You move the red one around and try to eat the green before the yellow eats you. And it has 4 levels. It's kind of cool. Okay, so this is about microcontrollers. So what is a microcontroller? Well, it's a complete computer on a little chip. It's not quite as powerful as like modern PCs or Mac hardware, but it's really powerful and really cheap. So it's pretty much exactly the same as any other one, but it's on one chip, and there's often a little bit of extra hardware. So in most ones that are available now, like the ones on the Mini POV or all these things here, there are hardware timers in it. I'll mention a little bit more about that later. And there's also input and output pins that you can control with the software. And the software for microcontrollers is called firmware. It's not quite software because it's directly twiddling with the hardware, but it's not hardware, so it's in the middle, so it's firm. What does a microcontroller do? Well, it does absolutely exactly the same thing that all computers do, whether it's supercomputers or PCs or Macs or little microcontrollers. They fetch instructions from program memory, and they execute them. And that's all it does. Fetch the next instruction, execute it. Fetch the next instruction, execute it. It does that forever until you turn off the power. So how do you make cool things with microcontrollers? Well, first you have to have an idea of what to make. And then there's hardware and there's firmware. And you don't have to do it necessarily in any order. And then you just make something cool. So in software, most people go to hacker conferences, know something about software. Anyone who's done software knows that one of the things you have to do at the beginning is to do a hello world. So if you can have your development environment on your computer print hello world on the screen, then you can do just about anything. Well, the equivalent of that for microcontrollers is to make an LED blink. If you can make an LED blink, you can do anything, really. So, first of all, that was the idea, and here's some hardware to do that. Well, this is a schematic. Now, you don't need to be able to read a schematic to do cool things with microcontrollers, but I want to teach you just a little bit about hardware and electronics here, so you know what's going on in the background. You know, we're hackers, we're inquiring minds, and we want to know. So that big box in the middle, that's the microcontroller, a representation. And the little circle on the top connects to the plus battery. The 3 lines at the bottom connects to the minus terminal of the battery. The zigzag, that's a resistor. And that weird thing, that's an LED, a light-emitting diode. And I'm going to mention just a bit here by taking a little digression and teach you just a very, very little bit about electronics. So electronics is dealing with electrons. That's why it's electronics. So it can be analogous in many ways to water flowing through a pipe. So it's not water flowing through a pipe, it's actually electrons flowing through wires and parts. And there's this notion of current. That's one of the main things in electronics, and that's electrons flowing. The faster the electrons flow, the higher the current, and the unit of that is amps. And then a battery is like a pump pushing the electrons. The more it pushes, the faster the current goes, and the more the current, and that's volts. And then resistors is kind of like a kink in a pipe, and that'll slow the flow down. And the measurement of that is ohms. And there's a simple relationship with all these, which is Ohm's law. And like I said, you don't need to know all this, but you can see that there is a relationship. If there's a kink, it'll slow down the current. If there's a bigger battery, it makes it go faster. And there's also a relationship with power, how fast the battery will wear down with all them as well. So a diode is a one-way valve. Electrons only go one way through a diode. An LED, light-emitting diode, when the electrons are going the correct way through the diode, it emits photons, and you make all sorts of lights like these. And a transistor is one other part. It's like a remote switch. You put a teeny little, it's got 3 terminals. You put a little bit of current on the middle terminal, and it allows a large amount of current to flow from the top terminal to the bottom one. And that's in the digital world. We use them as switches. So we either turn the large amount of current on or off. And a microcontroller is nothing but a bazillion transistors set up in a bunch of ways so it can do sequences of switchings on and off. Okay, so that's your very basic electronics. Firmware really is very much like software. So if you're familiar with software at all, one of the things you can do with software is make a variable that can be set to any value you like. And that's exactly the same in firmware. So if we have a variable x, we can make it be 1. One thing, though, with firmware is you try to think about the hardware while you're doing it, unlike with software. So with most microcontrollers, there are 8 bits. So the physical memory actually has 8 little bits that can be 1 or 0, and that's in binary. So that's why I put the leading zeros on there, and there are 8 places here. So that's really the only difference, is a little shift in the way you can think about it. Okay, but here's a difference. With software, you can't make output pins go high or low, because they don't exist. You don't have control over that. But with firmware, you do, and output pins are or input pins are often called ports on a microcontroller. So if I want to make a pin go high, I can do what that first line says. Port A equals 00001. And if I want to turn it off, I just make them all zeros. And that's it. That's firmware. That's an actual firmware program to turn a light on and then off. There's only one problem. Instructions take time, very little time. So, and it depends on the clock, and a clock is sort of a heartbeat for any computer. And with more modern computers, they're like 3 billion clock pulses per second. With a microcontroller, it's more like 1 million to like 20 or 50 million. And still, instruction happens